Hello everyone. In this video, I'll be talking about the introduction of the NCERT chapter Work, Energy and Power. Now, the terms work, energy and power are frequently used in our everyday life. But in physics, the words have got a precise and definite meaning. In our everyday life, we may refer to work as a man lifting a heavy load, a student studying, and energy is defined as the capacity to do work. It's similar to what the physics meaning states, and power is the rate at which this energy is spent. Or it, for example, in a boxing match, a boxer is said to be powerful if he is able to hit hard. These are the everyday life situations in which we use these terms. There is a loose correlation between the physical definition and the physiological pictures these terms generate in our mind. Now, first we can see about the scalar product. Before studying about work, we should know about this, that is the scalar product. A scalar product is a scalar from the product of two vectors. It is also called the dot product. The scalar product of two vectors A and B is defined as A dot B is equal to AB cos theta, where theta is the angle between the two vectors, as shown in the figure. There are two vectors A and B, and the angle between them is theta. Then the second figure shows the projection of B on the vector A, that is B cos theta, is the projection of B on vector A. Similarly, A cos theta is the projection of A on vector B. The laws of scalar product. First one is the commutative law, which shows that A dot B is equal to B dot A. That is, A dot B is equal to magnitude of vector A into magnitude of vector B into cos theta. And B dot is equal to magnitude of vector B into magnitude of vector A into cos theta. We know that magnitude of magnitude of A into magnitude of B is equal to B into A. Hence, commutative law follows. Then, second is the distributive law. That is A dot B plus C. That is equal to A dot B plus A dot C. Similar to the way I proved commutative law, this law can also be proved. Now, the other law is A dot lambda B is equal to lambda into A dot B, where lambda is a real number. Now, from definition of scalar product, that is A dot B is equal to magnitude of A into magnitude of B into cos theta. Now, from that, we can find these two, that is A dot A. That is, A is the same vector, hence the angle theta between the is 0. That is, cos 0 is equal to 1. Hence, A square. A dot A is equal to A square. Similarly, if A dot B is equal to 0, that means that the angle between vector A and vector B is 90 degree, or else A and the vectors A and B are perpendicular. Now we can see work. Okay, now work. Consider a body of mass which is subjected to a force of F at an angle of theta degree to the horizontal surface. Then when the after a time t, the body travels a distance d, then the work done by this force is given. That is, the work done by the force is defined to be the product of component of the force in the direction of the displacement and the magnitude of this displacement. That is F cos theta into d, or W is equal to F dot d, which is the dot product of force and the displacement vector. So work done can be 0, positive and negative. Work done can be 0 if the force applied is 0, the displacement is 0, or theta is equal to 90 degree. Examples include, if we are pushing on a wall, we are applying force, but there is 0 displacement since the wall is not moving. Here the work done is 0. Similarly, a coolie carrying a weight on his head. In this case, the force is perpendicular to the direction of motion, since the coolie is carrying it on his head and walking. In this case, the theta becomes 90 degree and hence work done is equal to 0. Work done is positive when there is an energy gain. That is, work done is positive if a body moving with a velocity v, the velocity increases when a force is applied, then the work done is positive. On the other hand, if the velocity decreases or there is deceleration, then the work done is negative. Negative work is done when the angle between the vectors f and d is greater than 90 degree. Example include the case in which we are walking. In this case, we are pushing on the ground to propel us forward. In that case, the force is towards backward while the displacement is towards the front. Hence, the theta is 180 degree and cos 180 degree is equal to -1. Hence, the work becomes negative. Now, kinetic energy. The kinetic energy of an object is the measure of the work an object can do by virtue of its motion. It is the energy possessed by a body if it is in motion. It is a scalar quantity and is given by half mv square, where m is the mass and v is the velocity with which the body is moving. Now we can see an important theorem known as the work energy theorem. This relates the work and energy. That is, the change in kinetic energy of a particle is equal to the work done on it by the net force. That is, when a force is applied, if work is done on a particle, then there will be a change in kinetic energy. That is what this theorem basically states. It can be proved as shown. By third equation of motion, we have got the equation of motion v square minus u square is equal to 2as, where v is the final velocity and u is the initial velocity, a is the acceleration of the body and s is the displacement. Now if we multiply both sides by m by 2, then it becomes half mv square minus half mu square is equal to mx. We know that from Newton's second law of motion, the product of mass and acceleration for a uniformly accelerated body is force. So it becomes F into S. Now if we replace S by D, as we have seen in the definition of work, displacement is given by D. We get half mv square minus half mu square is equal to mad is equal to fd, and f dot d is equal to work done, that is w. Hence, it is proved the work energy theory is proved. That is Kf, which is the final kinetic energy, and Ki, the initial kinetic energy. The Kf minus Ki is the change in kinetic energy, and it is equal to the total work done. So this is the end of this video. In this video, I have just given a brief introduction about work, kinetic energy, and the work energy theory. If you have got any doubt in any of the topics discussed in this video, please comment in the section below this video. Thank you.